ఓకే, సెకండ్ ఇయర్ సిలబస్లో ఫస్ట్ లెసన్ వచ్చేసి సాలిడ్ స్టేట్. ఓకే, సో మ్యాటర్ కెన్ బి మేడ్ అప్ విత్ ది పార్టికల్స్. సో బేస్డ్ ఆన్ ది పార్టికల్స్ అరేంజ్మెంట్, again matter can be classified into three types, that is the solids and liquids and gaseous. So this classification based on the particles arrangement and intermolecular forces between the particles, based on the intermolecular forces. Come in. Intermolecular forces, based on the intermolecular forces, particles arrangement, matter can be classified into three types: solids, liquid, gaseous. So in solids, particles are closely packed, are closely arranged when compared to liquids. In liquids, particles somewhat distance is there. So in solids, strong attractions or strong intermolecular forces present. In liquids, weaker than the solids, greater than the gaseous. In gaseous, particles are randomly moved in all directions, whereas in liquids and gases, in liquids and solids, they are not in motion. In liquids, some motion, very low motion is there, but in solids, particles fix their specific position. So this is the classification of the matter. Our topic about solid state. So again, solids are classified into two types. Again, solids are classified into two types. That is, one is the crystalline solids, second one is the amorphous solids. One is the crystalline solids. Crystalline solids. Second one is the amorphous solids. Crystalline solids and amorphous solids. Again, solids are classified into two types. One is the crystalline solids, second one is the amorphous solids. So in crystalline solids, constituent particles means, if you take NaCl, here NaCl is the constituent particles and Na plus is the constituent particle, Cl minus also constituent particles. So in solids, constituent particles, they may be atoms or ions or molecules. Okay, atoms aina avvachu, ions aina avvachu, molecules aina avvachu. So in crystalline solids, constituent particles are arranged in a regular manner. In constituent particles, in crystalline solids, atoms or constituent particles are arranged in regular manner. Okay, whereas in amorphous solids, constituent particles are arranged in irregular manner. So that's why crystalline solids have long range orders. Crystalline solids have long range orders. In amorphous solids, they have short range orders. So long range orders, short range orders means, if you, for example, if you take one crystalline solid, this is one crystalline solid, this is one amorphous solid. So if you observe this crystalline solid from first position to last position, their arrangement is same. That's why they are regularly arrange అయ్యి ఉంటాయి అన్నమాట. Coming to amorphous solids, if you observe here, we find out different atoms or ions or molecules. Coming to here, we find out different atoms or different ions, their arrangement is different. So that's why this is irregular manner, they have short range order. These are regular manner, they have long range order. For example, ఇప్పుడు క్లాస్ రూమ్లో కూర్చోబెట్టాం అనుకోండి, లేదా ఒక సినిమా హాల్లో లేదా ఒక ఫంక్షన్లో పెయిర్స్ని కూర్చోబెట్టాం అనుకోండి, ఒక జంటు ఒక లేడీ, ఒక జంటు ఒక లేడీ, ఒక జంటు ఒక లేడీ, ఒక జంటు ఒక లేడీ అలా కూర్చోబెడతాం. సో అవి షార్ట్ లాంగ్ రేంజ్ ఆర్డర్స్, మీరు ఎంత లాంగ్ వెళ్ళినా అదే ఆర్డర్లో మనం అబ్జర్వ్ చేస్తాం. షార్ట్ రేంజ్ ఆర్డర్స్ అంటే ఏంటి, కుర్చీలు తీసి అన్ని తీసేసి అందరినీ నించోమన్నాం అనుకోండి, ఒక ఆర్డర్లో నించుంటారా, ఇద్దరు అబ్బాయిలు ముగ్గురు అబ్బాయిలు ఉండొచ్చు, ఇద్దరు ఆంటీలు ముగ్గురు ఆంటీలు ఉండొచ్చు, ఆ డిఫరెంట్గా నించుంటారు అనమాట. అక్కడ షార్ట్ రేంజ్ ఆర్డర్స్ ఉంటాయి అనమాట. అంటే ఒక మీటర్లోనే ఒక అబ్బాయి ఒక అమ్మాయి ఉంటారు, మళ్ళీ నెక్స్ట్కి వెళ్తే మళ్ళీ ఇద్దరు అబ్బాయిలైనా ఉండొచ్చు, ఇద్దరు అమ్మాయిలైనా ఉండొచ్చు అనమాట. అది షార్ట్ రేంజ్ ఆర్డర్స్. సో డ్యూ టు దిస్ అరేంజ్మెంట్స్ crystalline solids have sharp melting point. Due to this irregular manner or short range orders, they don't have or does not have sharp melting point. Okay, and crystalline solids are anisotropic. Coming to amorphous solids, these are isotropic. Okay, anisotropic and isotropic. This is the classification of the solids into crystalline solids and amorphous solids. So again, solids are classified into two types, crystalline solids, amorphous solids. So crystalline solids have, in this constant, particles are arranged in a regular manner. Coming to amorphous solids, particles are arranged in irregular manner, and they have long range orders, these have short range orders. These have sharp melting point, these doesn't have sharp melting point. These are anisotropic and these are isotropic. Again, what is anisotropic and what is isotropic? So if you take NaCl crystal, Na plus Cl minus, Na plus Cl minus, Cl minus, Na plus Cl minus, Na plus, Na plus Cl minus, Na plus Cl minus, Cl minus, Na plus, Cl minus, Na plus. This is the NaCl crystal. If you observe this crystal in this direction, we find one chlorine atom, then chloride ion and Na plus ion, then chloride ion, then Na plus. If you observe this molecule or this crystal in this direction, in this way we find out only chloride ions. Okay, so this property is called anisotropic. Coming to isotropic, so in amorphous solids, this is the amorphous solids. If you explain the isotropic property for amorphous solids, you must take very small portion. When you take the very small portion, in small portion there is an order. If you observe any direction, we find out same ions or same atoms or same molecules. So that's why amorphous solids are isotropic, whereas crystalline solids are anisotropic. This is isotropic property and anisotropic property. Later, types of crystalline solids. రికార్డ్ అవుతుందిరా ఒరే నాన్న, దాన్ని ఏం చేయకు నువ్వు, ఈ బోర్డు బాగాలే. టైప్స్ ఆఫ్ క్రిస్టలిన్ సాలిడ్స్. సో అగైన్ crystalline solids are classified into 5 types. Again, crystalline solids are classified into 2 types, crystalline solids, amorphous solids. Later, crystalline solids are classified into 5 types. That is first one is the ionic crystalline solids. Ionic crystalline solids. Second one is the covalent crystalline solids. Covalent crystalline solids. And third one is molecular crystalline solids. Molecular crystalline solids. And the fourth one is